Hello everyone, so my name is Yue Yang. So today I would like to share my latest research, and this is also the video abstract of our papers published on the transplanters. And this is a joint work with my supervisor, Dr. Ramezani, our person in town, Jacob Elmasry. So in recent years, the e-hailing service has reshaped our lives in many dimensions, and there are so many e-hailing platforms emerging in our lives, like the Uber, Lyft, and Didi. Thanks to these services, passengers could type the origin, destination, and departure time in the mobile application. Perhaps they will get a ride within 5 minutes. This platform collects the passenger requests, geographical coordinates, and the occupancy status of the drivers, and then periodically dispatch the idle driver to service passengers. These platforms are typical two-side marketplace and enable individual passengers to match and transact with independent drivers. On the supply side of the platforms, drivers are making their working decisions based on their income and time flexibility. And there are many two types of drivers in the market. The first is full-time drivers, such as the taxi drivers and UberX drivers in the Uber platform. And the second one is part-time drivers. So these drivers share their vehicles when they are off duty, and they enjoy the work-life balance. On the demand side of the platforms, there are also different types of passengers, like the single trip rider, where passengers book a taxi for a single trip, and another is like ride-sharing riders, so where the rider shares the trip with other passengers. The data used in this study is collected from the Didi Gaia data sharing project, and the project shares the complete ride trajectory and order data of Didi Express and Didi Premier. These are two types of primary services in the city of Chengdu. The Chengdu is the largest city of southwest China, and there is a relaxing tea house cultural and delicious food that is famous for its hit in Chengdu. And this is also a good place to see the China's cutest resident, the giant pandas. Okay, so the upper figure presents a daily number of the unique drivers and trip holders from the datasets. And the figure illustrates there is a weekly pattern of the number of drivers and orders. Fridays and Saturdays have the most number of drivers and orders, while the Mondays have the least number of drivers and orders. And the below figure illustrates the hourly number of active drivers in the markets, the number of entries to the markets, and the number of exits from the markets in November 8th. So we can observe there is a stable trend of the number of active drivers in the daytime. So however, the hourly number of the entries and the exits from the market changes significantly. So therefore, the market behavior of the drivers should be considered in the supply analysis for the e-hailing markets. And moreover, an accurate prediction of the supply capacity is really a challenging task. So to effectively capture the working duration of each driver, their operation period within a day can be divided into one or multiple working shifts. So here we define the gap between the two sequential orders and the time gap between the drop-off time and the pickup time of two successive service passengers. And that is once the time gap between the two service orders greater than 2 hours. So this is considered a break between two shifts. So to investigate the characteristic and the behavior patterns of different drivers in the e-hailing markets, so we further introduce the 6 operation features of each driver in a day. So there are the number of shifts, average number of service orders per shift, start time of the first shift, average shift duration, average occupied duration per shift, and average occupied distance per shift. So after that, the driver will be clustered into 3 clusters by the k-means clustering method. So according to the mean values and the standard deviation of these 6 features, we could find that the cluster A are part-time drivers working flexible hours, cluster B are part-time drivers working evening, and cluster C are full-time drivers. So the below figure further presents the percentage and absolute value of drivers in each cluster of 2 weeks. So drivers of the cluster A and B are approximate 50% and 35% of the total supply in each day. So therefore, we can say the part-time drivers make up the 85% of total supply on average in a day. The number of active drivers in e-hailing markets during a day is also predicted based on the simulation-based prediction in this study. So each individual driver is viewed as an agent, and the simulated drivers start and end their shift based on the clustering analysis and the statistic estimation of their features. So after a 4-day simulation, the number of active drivers can be finally estimated. So the figure compares the empirical result with the prediction result, so which demonstrates the proposed method can effectively predict the empirical data over the different days. The clustering and prediction analysis discussed in this research provide us a key insight into the characteristic and the market behavior of the e-hailing drivers. So according to the results, so we could further design a driver incentive to attract more drivers to work in the all undersupply scenario. So another application is that we could impose a taxi policies for drivers and to manage the congestions in peak hours. And finally, we can use the characteristic and behavior of different clusters to attract more drivers to share their vehicles for ride-sharing service. So this work had analyzed the behavior pattern and characteristic of the drivers in the e-hailing markets. And we collect the data from Didi Gaia sharing project in Chengdu City. And we use like clustering and prediction method to get a result. And after that, various policy and operational recommendations are provided to tackle the mismatch of the supply and demand. The full paper can be found in the below link. And thanks for your attention.